Welcome back, everyone. I'm just making the next little introduction to the video where we're going to work on some skills out of the textbook, and it's called solving by inspection. And we just need to understand what this word inspection means. And here's a really good example. The other day, I was driving down the street and there was a guy standing there with a pair of binoculars looking up at the top of the power poles, looking at the electrical cables, looking at the insulators, looking to make sure that everything was okay, nothing was rusted or corroded or damaged. So he can do that job looking from the ground. And he was just using a pair of binoculars to look and inspect and make sure everything's okay. So we're doing the similar sort of thing. We've got some equations. Remember from the previous video, we've got an equation here. There's an equal sign in here. So we're going to call it an equation. And we've got 3. I read this as 3 times something. And I covered that in the last video here. And if I solve this by inspection, I read this as 3 times 4 equals 12. Okay, so it's not dissimilar. Guys, remember back to the days of primary school where you have boxes, worksheets loaded up with boxes, and you've got to come in here and start to think about what that needs to be to make that true. And if you did it correctly, you'd write times 4 in here. Okay. But there's nothing stopping you, if things are a little bit more difficult than this, there's nothing stopping you thinking, oh, could that be 3 times 1, 3 times 2, 3 times 4? Oh, 3 times 4 works. That's equal to 12. So my answer here, and this is what I'd like you to write, and this is what I'll show you in a moment, on the whiteboard, is that your answer is going to look something like this: x equals 4. Okay, and it's really, really important to remember, and I'm just going to say it again before I stop, and I'm going to draw this on the board in a moment. The left-hand side of the equation must equal the right-hand side. So we've talked about 2 words here. One's being inspection, and that's just looking in. And at any moment, when you can see the answer and you're confident that you've got the answer, you can stop doing any more algebraic manipulation. You can just look. If you can look in there and write the answer, good for you. And do that. Solving by inspection is a great way to do things. And the other important thing to remember is the other word must. And what it's telling us is that there's no other options. When you're told you must do something, you've got to do it. All right? So if I say the left-hand side must equal the right-hand side for something to be true, that word in the middle, must, is a very important word. So think about those things, and I'll show you a few more examples on the whiteboard. Now, we talked about solving by inspection, and that's just having a look to see what the answer is. And I imagine you've been doing a lot of this kind of stuff in primary school, where I call them boxy questions, right? There's a box there and you've got to fill it in. And you've been doing that stuff forever and a day, and 4 plus 3 equals 7, and that equation is true. So similar sort of thing here, 8 times x, for example, and that's equal to 64. I'm just using square numbers here. And we know that this value has to be 8 times 8, so x is equal to 8 for that to be true. And I guess let's do one more up the top here. And what do we got? Something requires a little bit more thinking. We've got 7 times x is equal to, no, I'm going to change that. Sorry. 7 plus x, and maybe that doesn't work so well, so let's just do this. Equals 2 times x. Okay, what is the value of x? We've got x on the left-hand side and x on the right-hand side. They have to be the same number, and it has to be true. So I'm thinking 7 plus 7 is the same thing as 2 times 7. So 14 on the left-hand side is equal to 14 on the right-hand side. And so our value of x has to be, in this situation, we have to have x is equal to 7 for that to be true. And there's only one possibility here for a solution, and that is x equals 7. So I guess let's try one more, and we've got this set up here where we've got some brackets. We have to think about BODMAS here, and I think this is kind of like one of the examples that I used in the introduction. Okay, so we're looking inside the brackets and we're solving by inspection. We have to work out what the value of x has to be, and possibly what we could do is cover up this bit here and start thinking about some number, subtract 5 has got to be 11. So all this stuff in the box has to equal 16, but we've already got its implicit multiplication there. We've already got 4 times something is equal to 16. And so while we're thinking like that, 4 times 4 is the obvious one here. So when we come back inside the brackets here, we're thinking all this stuff inside the brackets when we apply BODMAS is the very first thing that we've got to do. So this has to be equal to 4 up here. And so the value of x has to be, in solving by inspection, the value of x has to be 3. 3 plus 1 is equal to 4. 4 times 4 is 16. Subtract the 5 and that's equal to 11. And that's the kind of thinking that we're going through when we're solving by inspection. We're not writing a lot down. And I've written a fair bit for you to just see what's going on. And what we need to just do as our final answer, and perhaps I could write it all out again here, and when you see it, I always want you to write down the equation. You could just go comma x is equal to 3 for that to be true. And that would be a suitable way to write your answers. So I'm going to pause and clean the board and come back with a few others to work on. We're solving by inspection here, and here's another nice little setup here. We've got some number x, who knows what this number is yet, I don't know. We're writing it out and we're trying to solve this equation, and the value of the pronumeral has to be the same in each case. So here's a good example where the brackets don't actually mean much, and I could rewrite this as 2x plus 1 is equal to 19, and that helps my thinking out a little bit here. I know I've got some number that I'm going to double, and that's a timesing by 2 bit, and then I'm going to add 1. So in my mind, and I'm perhaps thinking about it like this, and that's really easy for me to see now. So this number has to be, the value of x must be 9. Okay, so when I come back to my original equation, I've got 9 plus, I'm doing this bit in the brackets here. I was pointing at it, but I realized that you guys can't see that. 9, this value is 9 plus 1, well that's 10, and that's equal to 19. So it all checks out and it all works. So there's a question what's in the textbook for you, but it's leading to a bigger thing, and they're talking about consecutive whole numbers. I'm just going to put numbers like that. And they've got this set up for you where it's looking like this. You've got the same bit, if you recognize that from the previous question. So the work that you're doing here is actually consecutive numbers in disguise, right? And x plus 2, and that's all equal to 45. Hopefully I haven't run out of room on the board there. What does that mean? We've got 3 values of x, and perhaps we could do it like this. If we're thinking about our algebra, we could write, we've got 3x plus 1 here, plus another 2 here. So I'm going to write it as this is equal to 45. Okay. So it could be a guessing game. You could realize that you've got 3 numbers that are consecutive, so they're next to each other on the number line, and you could do this, 45, how many 3s, and what do we get to? We get to 15. So one of our numbers, I suspect, is 15. All right, so that's kind of like creating an average, and it works in this situation here, where in this guessing game we've got 3 numbers that we're going to add together, and I've just called them circles, and that's going to be equal to 45. And in this situation, an average is like the middle. Okay, so let's try this. And let's pick the numbers either side of 15. So that would be 16 and 14. And that does equal 45. I just lost my thought there for a moment. But let's maybe take this idea out of here and use inspection to solve this. 3 times something plus another 3 is equal to 45. Now, what does that mean? If I'm thinking I'm adding 3, so why don't I just think about this as 3 times something equals 42. And I'm thinking that that value of x has to be a 14. Okay. So there's my first number in the sequence that I need of 3 consecutive numbers, and this is what I'd like you to think about here. And this, if we draw a number line here and we have 14, 15 and 16 as our numbers, we know this. So this is a good good way to think about things. I'm going to call that x. Well, 15 is equal to 14 plus 1. And I said, that could be the same as x plus 1. So if I'm calling this 14 as x plus 1, 15 is just add 1. So 15 is the same thing as x plus 1. And then finally, we've got 16 is the same thing as x plus 2. So what I'm just trying to do here is just trying to help you link up some of the algebra. And this looks, if we go right back up to the top here, this kind of looks scary, this value of x, and we figured out that was 14, and this guy here was 15, and this guy here is 16. And so the number has to be the same. So x is 14, this is 14 plus 1, which is 15, and then the same value, 14 plus 2, well, that's 16, and that's how these numbers drop out. And that is a good starting point, a good launching pad for you to be thinking about consecutive numbers. To wrap up this video, I've got a little bit of, they are questions in the textbook, and we need to start thinking about, like we did in the end of the last video, what values could we use to make this true? And let's play this game. If we make them both the same and equal to 4, that works, okay? Now, we could make x equal to 8 and y equal to 0. And then we could decrease this number and increase this number and get a range of solutions. Okay? And they're all valid solutions to this equation that we've got here. We could also use negative numbers. Why don't I make x equal to -1 and y equal to 9? And that works, and we can get solutions to make this true. So they're things to think about. So why don't I try a new equation here? X times y is equal to 6. Now, what are we thinking about here? We could make x equal to 6 and y equal to 1, and that would be true. We could make x equal to 1 and y equal to 6, and we've got 2 solutions here now, and we could play this game x equals 2 and y equals 3, and x equals 3, y equals 2, and we could generate a whole bunch of solutions there. But is that it? Is that it? What other things could we do? Could we make x equal to -6 and y equal to -1 and use our knowledge of negative numbers here, because 2 negatives multiplied together will produce a positive answer as the outcome here. So that's one solution, set of solutions, and we can apply that to all this stuff over here and generate new solutions. We're getting a lot of solutions here, and the only other thing that I can think of is perhaps we could do √6 times √6, and that's equal to 6. Would be another way to generate some solutions here. And I'm quickly running out of board here, but there's one more thing that I want to try with you, and it's using let's just do this. We're having thought about all those things, why don't we set up an equation that looks like this, purely algebraic, whatever number we slot in here, we're going to add them together on the left hand side, and then we're going to multiply them on the right hand side. And we need to think about what kind of solutions that we can have here. And I'm thinking, well, why don't we make them all the same and make them equal to 0? So on the left hand side, 0 plus 0, and on the right hand side we've got 0 times 0. The left hand side is going to equal the right hand side here, and so that's a valid solution, so that'll be true. I'm playing this game again, and I'm thinking this might work. 2 plus 2 is the same thing as 2 times 2, and so I've got another solution that is true here, and I'm racking my brains thinking of others, but I can't at the moment, and there may not be any other solutions to this. So here's a good way for you to play with this, and maybe you might discover another solution to this, or maybe not. And that's the whole game that we kind of play when we do this kind of work. All right, thank you.